Hello guys and welcome to another video of the UCAT Study With Me series 2019. Today we're going to go through a few quantitative reasoning questions, and yes, we'll see how it goes. We'll sort of go through how I work through the questions, and I'll try and give you a few top tips as I do the questions. So getting on to Medify, let's go to the start practicing page. And yes, let's just get cracking with a few quantitative reasoning questions. There are 430 stems in total. Gosh, okay, so ideally I should have a calculator at hand as well. Okay, so this is the table. Okay. The total adult male population in Sweden, how many men are considered obese? Okay, so obese is when you have anything over 30, great, so Sweden has a population, or 11.7% of Swedish men are obese, so 4.235 times, or 11% is, I'm going to put it in sort of a decimal format, is equal to 0.495, so that should be 495,000 people. That's the answer. Great. So you see I'm using sort of shortcuts already. I'm converting percentages into decimals, which makes it far easier. Dan weighs 82.3 kilograms, his height is 172. What is BMI score? So the BMI equation is weight in kilograms divided by height squared. So 1.72 times 1.72 is equal to 2.9584. Now what I might do is in the exam you do have a whiteboard with some pen and paper, so just jot down 2.9584, and then we're going to clear that using the keyboard. 82.3 divided by 2.9584 equals 27.8. Perfect, that should be correct. 26% of people with BMI greater than or equal to 30 have obesity grade 3, and 38% have obesity grade 2. Okay. What percentage of the total adult female population of Portugal have an obesity of grade 1? Okay, so in Portugal we have 13.6% of women are obese, 13.6. So these percentages, so within the obesity category you have 1, 2, 3. So this 13.6 percentage category, the number of people behind that, then can be split into category 1, category 2, category 3, depending on how obese they are. So so we need to work out obesity grade 1. So 26 add 38 is 64. So just writing it down. So 100 minus 64 is 36%. So I need to find out 36% of 13.6. So let's just do 13.6 times. Let's convert 36 into a sort of decimal. 0.36 equals 4.896. That's perfect. Okay, next question. What is the average percentage of adolescents that are not obese from the European countries with the 3 highest rates of adolescent obesity? Okay, so the 3 highest are Great Britain, Germany, and Belgium. So what I need to do is I need to find out the average. So I need to take away this number, 100, like these numbers from 100. I need to add them together. So 100 minus 22.6 is 77.4 plus 79.2 plus 83.8. 3.8 equals, divided all by 3, 80.13. Perfect. Great. Okay, so let's mark that quickly. Whew. So do you see, it's knowing the calculator and being able to use it is the fast, the way to do all these questions as fast as possible. Great, we've got these questions right. Let's do some more questions. This is quite fun. So, right, we've got a graph here. 6 groups of pupils are selected from each year group in a school and tested for IQ. There's a scatter graph of 24 pupils. Each dot is 1 pupil. What is the average IQ of a pupil aged 10 years old? So this is in months. So if it's 10 years old, it will be 120. So of 120, of 130, 125, 110. Let's pull up a calculator quickly. right? So 130 plus 125 plus 110, enter. Divide that by 3 because we're working at an average. That's 121.666. So they've given us whole numbers here. So we're going to round 121.66 up to 122. That's how you round numbers, right? What is the average age of a pupil with an IQ of 110? Okie dokie. So let's go along this way. Okay, so let's quickly do this. So you have 90 plus 100 months plus 105 months. So what I'm doing is I'm going along here just looking for each pupil and their age. I have 115 months, and then I have 120 months. Equals, then I have 5 kids in total. Yeah, 1, 2, 3, 4, 5. Divide it by 5. I should get 106 months, that's the average. So what proportion of pupils have an IQ below 80? Alright, so we have 24 pupils in total. 80 is here, it is below 80, so it has to be less than 80. So 1, 2, 3, 4, 5. So we have 5 kids divided by the total number. That gives us 0.208, which is equivalent to 20.8%. So we're going to round it up to 21, as you round up numbers standard. What is the percentage increase between the worst performing and best performing people? So percentage increase, you work it out as the difference divided by the lower number. So the lowest number of the worst performing people is 60, the highest is 130. So the difference firstly is 130, take away 60, which is 70, okay? Then we divide 70 by the lowest number, 60, which is 1.16, which is equivalent to 116%, or 116.6%, which rounds up to 117%. Next, let's mark this. They should all be correct, but we'll see. Fantastic, everything was correct. So, let's do the next question. Quantitative reasoning. Now, I do want to say the times that Medify shows on my computer is a bit funny because when recording this, if the keyboard goes funny, I just start the question again. So don't worry about the time it takes me to do the question. Here, the table shows below the distribution of employees within an international steel production. Okie dokie. Just look at that. Age, gender. What is the probability that an employee chosen at random is a member of management and has a postgraduate degree? Whoa. Okay. So how many employees? We've got 20 employees. So the chance of being in management is, so there are 2 out of 20. So the probability is 2 divided by 20, which is equal to 1 over 10. That's the probability of being in management, and has a postgraduate degree. So 1, 2. Oh no, a postgraduate degree is a master's or a PhD. So it's 1, a master's, a PhD, 2, 3, 4, 5. So 5 out of 20, which is 1 out of 4. So the multiplication will be 1 over 10 times 1 over 4, which is 1 over 40, because probabilities you multiply them. What is the percentage difference between, in the average IT salary, whatever? Okay, so IT salary, the average salary of an IT employee, gosh. This is going to be a hard one. Okay, it's not hard, but we're going to work it out. So 120,000 plus 105 plus 120 again, plus, then we've got one more down here, 24,000 equals, we divide that by 4. That gives us the average IT salary, which is £92,250. Then the HR employee, human resources, there is 21,000. Now, for percentage difference, it's 92.5 minus 21 equals 71.25. So 71.25 is the difference in the actual salary. So the percentage difference would therefore be 71.25. So the difference is, that is a difference. Divide that by 92.25, which gives us 77%. There we go. What is the average salary of a divorced employee? 50, okay, just add them all together then. Calculate please. So 50, add 96, add 35, add 66, add 105, equals, there was 1, 2, 3, 4, 5, divided by 5, 70.4. Which department has the largest salary per employee? That's a good question. So I'm going to eyeball this. It looks like management, to be fair, because for the two management positions, they both have like over 100k, whereas stock control is quite low, marketing is quite low. IT is quite high, but then this 24,000 really drags it down. So I'm thinking it's going to be management. Right. Great, let's mark this. Okay, first question was wrong. Why? Oh, only one management member. Wait. Okay, so one employee out of 20. Okay, the first question was wrong, fair enough. My probability calculation was wrong in that case. It is, yeah, fair enough. It is like, postgraduate degree and management in this cohort. Okay, fine. Should have just looked it up in a far simpler way instead of having done the calculation. Okay, fine, fair enough. That was a funny mistake then. And a lot of people have made that mistake also. Right, so let's do one more question actually. Okay, Petrovna purchased a small bag of wooden 2D objects to teach his son about probability. What is the probability of Alexander picking out a circle random? Which is, okay, so a lot of shapes there. So 1, 2, 3, 4. Okay, counting this is going to be an absolute pain. Right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. I hope that I counted that correctly. Out of 35, the number of circles 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 divided by 35. 37. So let's go with that. Fingers crossed. Alexander picks up 3 squares at random in a row and places them on a table. What is the probability of Alexander now picking up another square at random? 1, 2, 3, 4, 5, 6, 7, 8. 8 squares. So remember, the probability changes after you remove every square. So initially, the chance of him getting a square was 8 out of 35. Then we multiply that by 7 out of 34, and 6 out of 33, then 5 out of 32. So, yeah, let's just do the first line. So 8 times 7 times 6 times 5, which is 1680, over 35 times 34 times 33 times 32. 1, 2, 5, 6, 6, 4, 0. The calculation will be 1680 divided by 1680 divided by 1, 2, 5, 6, 6, 4, 0. Well, calculator. 1680 divided by 1, 2, 5, 6, 6, 4, 0. Oh, that doesn't work. Oh, right, sorry, okay, my bad. We're not trying to work out the total probability, we're just working out the probability of the next thing happening. So it's just going to be 5 over 32. I'm overcomplicating things. 5 divided by 32. Sorry. And also I should have been multiplied, should have been added. So maybe I should have added those probabilities. No, I wouldn't have. All shapes of the prime number of sides are removed from the bag. What is the probability that now Alexander will pick out a hexagon? 1 is not a prime number. So they remove 3, 5. That's all. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I'm gonna go with 8. So now from 35 there are now 27 shapes. Probability of getting a hexagon is 1, 2, 3, 4, 5. So 5 divided by 27. 5 divided by 27, which is 18, so 19%. Alexander picked out a shape 100 times, putting each shape back after every time. He recorded how many times he picked out each shape. How many times did he pick out a triangle? As in, you can't tell, really, because it can really vary. It should be probability, like what's the probable chance of him picking out a triangle, so we can't tell. Maybe I'm just rushing now. The shapes cost 13 pence per number of sides. How much in total did Petronova pay for all the shapes? You're joking? Oh my lord. That's a harsh question. Okay. So 35. So you've got circles, triangles, squares, pentagons, and hexagons. How many circles do we have? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. What? 1, 2, 3, 4, 5 triangles. Yep. 1, 2, 3, 4, 5, 6, 7, 8 squares. We've got 1, 2, 3, 4 pentagons. And we have 1, 2, 3, 4 hexagons. And technically this all should add up to 35. That's what, 18. Oh, it doesn't. 34. Oh, that means all the calculations are going to be wrong. No, there are 5 hexagons. I was right, 35 total. Great, ooh. So what's the total number of sides? So 13, add 15, add 32, add 20, add 30. Right, so just work out the number of sides for each section. Let's add the total number of sides together. So 13, add 15, add 32, add 20, add 30 times 13. So, what? No, what are you giving me? 13, add 15, add 32, add 20, add 30 equals 110 times 13. So £14.30. Whew, that was long. Right. Let's see what answer we get. Yay, everything was correct. Fantastic. Okay. Well, hope that was useful. That's another section done. Thank you so much for watching. If you have any questions about quantitative reasoning, then please do comment down below, and I'll be more than happy to answer your questions. As always, thank you so much for watching, and I'll catch you guys soon in the next video. Take care. Bye-bye.